Please stand. And let us pray. In nomine Patris et Filii et Spiritus Sancti. Amen. Credo in Deum, Patrem omnipotentem, Creatorem Caeli et terrae, et in Iesum Christum, Filium eius unicum, Dominum nostrum, qui conceptus est et Spiritus Sancto, natus ex Maria Virgine, passus sub Pontio Pilato, crucifixus mortus et sepultus, descendit ad infernus, tertia die resurrexit a mortuis, ascendit ad caelos, seded ad dexteram Dei Patris omnipotentis, inde venturus est, iudicare vivos et mortuos. Credo in Spiritum Sanctum, Sanctam Ecclesiam Catholicam, Sanctorum Communionem, remissionem peccatorum, carnis resurrectionem, vitam aeternam. Amen. In nomine Patris et Filii et Spiritus Sancti. Amen. Since about half the class is gone, we are going to hold off on the homework until tomorrow. I will go through any questions you might have on that, but half the people are gone, so checking off the homework will be a little premature. I do have a few new notes for you today, just as a teaser for the next topic, but I do want to entertain any questions that you might have. So, if there are any of these things on which you are stuck, now's the time to see what happens. Yeah, please.
Just number 5.
Okay.
That one was one harder.
Okay. This is, okay. Is this 3H-2? Or 3H-1? 1. Did I hand out 3H-2? Okay. And that's not due yet, so don't worry about it. 3H-1. Number 5?
Yeah.
Okay. I'll start you off. Y equals, bless you, negative x cubed plus x squared minus 4. And they're limiting x to the interval from -1 to 1. First of all, make sure your notes out and your worksheets are out. This means it's truncated, so I don't know exactly where we're going to clip it, but if it were not truncated, can anybody give me the basic shape this thing would have? What degree is it, first of all? Yeah.
3.
Degree 3. What's that called?
Cubic.
A cubic. This is a positive or negative cubic?
Negative.
Negative. So what would it look like? How do I draw it?
A swerve starting from the top and slowing down.
Yeah, so down, up, down. That's the basic shape of a negative cubic. Now there are 3 different versions. It could flatten out, or it could be a total wimp and not even flatten out. I honestly don't know, but somebody give me y prime. Actually, Blaise, help me out here. What's the derivative of this thing?
Negative 3x squared plus 2x.
And then nothing. Okay? Why would we take the derivative in this particular section? Mary, take over. What purpose does the derivative serve?
It gives you the tangent slopes,
Mhm.
so, and that's where it equals 0.
Ah,
So,
it might equal 0. Like on a full-fledged cubic, there'll be 2 places where the derivative is 0. On a triple root type thing, there's 1 place where the derivative is 0, and sometimes you'll have something that just wimps out. So, solve for me. How do you do it? Anybody, I'm just opening this up. Gum. Thank you. Sam, how do you solve this thing?
Use,
Gum. Okay. No gum?
no, it's a cop out.
Okay, fair enough.
Yeah.
Okay. Good. Just after the very first, everyone's going good. It's like, are you just trying to psych me out, or do you, like, did people hand out like candy something or other last hour or something? Don't try and incriminate other people. All right, tell you what. Keep going. Tim.
There's a GCF on the
Yeah, negative x sounds good. What's the last Yeah. Go ahead and solve.
Well, it's negative x equals 0, so it's
So x equals
0.
0. What about this one?
And then you add 2, so it's x equals 2/3.
X equals 2/3. Everybody go with that? Now, that tells us a few things. Which of these three types of graphs would it be, the top, the middle, or the bottom? This came up with two locations where the slope is 0. Yeah,
Is it the top?
it's got to be the top one. Here, you'd only get one solution. Here, you get no solutions at all, like two imaginary solutions. So again, you do not have to graph the whole thing in its full gruesome glory, but I do know that at x equals 0, and at x equals 2/3, I do not mean for these to be asymptotes, I'm just marking them here. So here's 0 and here's 2/3. What comes first, max or min? Go, Austin.
The minimum,
Why?
because it's gonna go down and up and back down.
Right, if you remember the pre-calc, a negative cubic is going to go down, then up, then down. That tells you a lot that calculus wants to ask you. There's a minimum first. So at 0, we're going to hit a minimum. I don't quite know where, but I do know this is at x equals 0, and this is at x equals 2/3. I have no idea how high or low it is yet. Shaylee, help me out with the height location of the minimum.
So you just plug it back in.
Right, plug it in. What do you get?
-4.
Yes, plug in a 0 and you get -4. I had to make those really huge, didn't I? So let's put a dot at 0, -4. That's the minimum. It's going to go back up from there. Can somebody tell me the height of the maximum? Feel free to use the calculator to assist. What do you do in order to find the height? Let me see. Nate. We got the height of this one.
You plug it back in,
Plug what back in?
2 over 3.
2 over 3. Grab your calculators. Here is another little bonus to having a graphing calculator. You can, and I'm trusting that everybody knows how to take 2/3 to the third power. But on your screen, just on the plain old home screen, negative. In other words, I want you to type this in, but every time you see an X, put 2/3 in parentheses. So negative parentheses 2 over 3, close parentheses to the power of 3. Then plus parentheses 2/3 squared, then -4. As soon as you're ready, hit enter. Do you get something that looks rather disgusting? Don't graph, but do it on the main screen. What do you get? Just give me the first 4 decimals.
I got a fraction. 4. -3.8518.
Yeah, -3.85185185185. The 2 is rounded. I don't want an approximate decimal. I want a fraction. Tell me how to do it. Go. What key is it? Math?
And then fraction.
Very first choice. So what's the fraction? Go ahead. Either one of you.
Negative 1 over 4 would be 7.
Yeah, this is 0, -4, and this is 2/3, -104 over 27, which is approximately -3.85, blah, blah, blah. Which is right here. Everybody clear? Your graph looks like minimum, maximum, minimum. Why did we spend all this time graphing? What possible, normally it says, say, hey, you got a max, you got a min, you're done. What have we missed? There's something in this problem we did not account for yet. Yeah, it's truncated. At -1 and at +1. somewhere around here and somewhere around here. Can somebody find me the height at x equals -1? Use your calculator. Oh, by the way, let me show you something else. This is actually pretty snazzy. Do me a favor, go to the y equals screen. Clear out any equation. Type just this formula in. Negative x cubed, negative x power 3, plus x squared, minus 4, and then hit enter. You notice when you hit enter, the equals sign on y1 turns dark. That means that that's active. That means you typed it correctly. So, hopefully. Quit out of that. And watch this. Have I talked to you about something called the store key yet? Where is it? It's right above the on key. STO. Do me a favor. Let's just try as a, see 2/3? Type 2/3. This is just as an experiment because we already know the answer to this one. 2/3, hit the store key, and then hit X. Did you get 0.66666, blah, 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 blah? Good. Now, tell me how to call up Y1 from yesterday, the day before. Sorry, people who are looking at home, all I did was this so far. The Y equals screen looks like this. I hope I'm on screen. Hang on a second. There you go. And then, yeah, and then on the main screen it looks like this. And then go where? Yeah, variables, which is right here. Sorry, this key right here. Where do you go now? Yeah, use the right hand arrow and go to Y variables. Now what? Select function, which it should already be on. And then what? Y1. On your main screen, you should have Y1, blink, blink, blink. How do you plug in 2/3? Parentheses 2/3, try it. See what you got? And then convert to fraction. I gotta get this on screen, sorry. Ta-da. So there's your -104/27. Okay? I'm gonna show you two new tricks here. Call up Y1 again. Step me through it, Mary.
Variables,
Variables,
y variables.
Y variables, function, and then hit Y1. Do me a favor though. Instead of parentheses 2/3, do parentheses X. So it looks like this. Hit enter. Notice something? Same answer, guess why? No pun intended. Because you stored 2/3 into X. Here's where the nice part comes in. Can you tell me the next value of X I want to try? Because I want to find the height somewhere else. There are two more values of X I need to find the heights for. 1 and -1. Let's try -1 first. Do me a favor. On your calculator, on the main home screen, do -1 store X. -1 store X. Refresh my memory, oh math people. Do you remember how to call up what you typed last? This is a very useful trick to know. Second, enter. Now, don't hit enter yet. So second enter, do that once. And now do second enter again. Do you see Y1 parentheses X? Hit enter now. It saves you a lot of typing. You can just replace the X and call up the previous formula. Now, by the way, you can always just go to variables, Y1. I just want to do Y1 parentheses, whatever thing we're needing. I got a -2 here. So I guess I was close. So we've got a -1 comma -2. Okay, what other height are we looking for? Go.
Well, I just have a question.
Yeah, go ahead.
Since 0 and 2/3 are already in between the integral, and we know that's the maximum, do we even need to find these?
Actually, yes, we do. Partially because what kind of a dot is it going to be open and closed?
Closed.
This part of the graph no longer exists.
Okay.
And this is going to be solid. You see why? How come? That's a good question. Why do we bother? Because that's a very good question. So we've got a min, we've got a max. Like, isn't that it?
Because those are now also max.
Yeah, what kind of max is a min?
Global,
True, and since they're snipped,
artificial.
artificial. Right, two artificial extrema just showed up. I want to try x equals 1. So whatever typing you want to use, I'll just do the old-fashioned variables, y variables. I don't know, it's probably not even on screen. There you go. Y variables, function y1, and I'll do parentheses 1. What do you get? Anybody? Yeah. -4. That is interesting. So it's going to be -1, comma, -4. Now I think we're ready to categorize these things. And again, this is 2/3, comma, -104 over 27. How many maxes are in this picture? Austin?
We have, 2,
Two. Name them.
-1, -2, and 2/3, comma, 104 over 27.
Right. Categorize this for me using the 4 categories. One of the categories is maximum.
So is that a global maximum,
Global. What else?
artificial,
Artificial.
it's not smooth, so it's the opposite of that one. but-
So it's
or
non-smooth.
not smooth.
And then maximum. Good. That's a global artificial non-smooth max. It's global. Why? Austin, stay with me. Why is it global?
Because it's the highest, well, because there's no other one that goes higher.
Right. It's the highest point in the entire graph because the graph is finite. It doesn't go forever. Why is it artificial?
Because it was set by the boundaries of the graph.
Right. It was truncated and set by the boundaries of the graph. Why is it non-smooth?
No, because it just ends with a point.
Right. If you hit your hand on it, you'll bleed. And that's a maximum because it's the highest point in that area. Blaze, categorize this thing. Global or local?
Local.
Local. Artificial and natural?
Natural.
That's natural. Smooth or non-smooth?
Smooth.
Smooth. Max or min?
Max.
Maximum. Okay. Becca, take this one from the bottom. Local or, this is a little tricky one. Local or global?
Global,
I don't blame you for saying that. They're tied for first place, the lowest point. Do you remember they qualify for that? If they're both tied for first place, do you count them both as global or both as local?
local,
I don't necessarily, has anyone ever heard of this old TV show called Highlander? Never heard. Okay. There was this big slogan, that premise is really pretty gruesome. Never mind, I'm not gonna tell you, I'll contaminate your brains. But there's this famous phrase where they're basically fighting to the death and only one of them can survive. And the phrase is, there can be only one. Well, there can be only one. I probably should not have used that metaphor. But there can be only one global. And if there's a tie for first, that means neither of them win. So what, I just sort of gave it away. So
They're both local.
they're both local. So Becca, take over. So it's local. Remember, if they're tied for first place, there are a few books that would say they're both global, but they're in the minority. Natural or artificial?
artificial.
Artificial. I'm going to abbreviate there. Smooth or non-smooth?
Smooth.
Non-smooth. Max or min?
Min.
Minimum. And Mary, take this one.
It's local,
Local,
natural,
natural,
smooth,
smooth,
and min.
correct. Questions? That answers that problem. I just did the whole problem for you, didn't I? Mary, questions? This making sense? All right. I want to show you just a taste of that's pretty much all the notes I have for this one. So you do all the other ones in a similar fashion. I just want to show you a little taste of why we're bringing this up. Why would we want to find maxes and mins? I mean, they're interesting to find on a graph, but is there any use to it? The answer is yes. Suppose here's a big wall. Here, bless you. This is a sheep pen made of fence. Congratulations, you're a farmer for the next 10 minutes. The total fence used is 1,200 feet. What I want to do is find out what dimensions of the pen maximize the area of the pen. Now, think that through for a second. You do not need fence on the side of the wall. The wall is taking the place of one side. You have 3 sides for your pen. Anybody know how long this is? I hope you say no. No, yeah. Good idea. And by the way, if it's up and down, I'd probably use what? Y. Does anybody know how long this is? Is it guaranteed to be the same as this? No. So what do you want to call it? If it's left, right? It's probably X. What about this? It's also Y, because that's a rectangular pen. Tell me, how much fence did you use? Sam, take over. According to the picture, how much fence are you using total? 1,200 feet is equal to what?
X plus 2y.
Very good. Y plus X plus Y should equal 1,200 feet. So basically X plus 2Y equals 1,200. That's at least something we didn't know before. Never heard so far. That's the setup. Now they're asking us to maximize the area. Now, they didn't tell us anything about the area as far as numbers go. How do you find the area? How would you compute the area if you did have numbers? Joe? Length times width. What would you get? So area is equal to what? X times Y. Does that make sense? I want to maximize this. Another way of writing that is find the maximum. We have been doing that for the past 3 or 4 class days. If you can give me a formula for area, we can step through how to find the maximum there. So tell me, A is equal to X times Y. How do you find a maximum in our class? Yeah. Yes, welcome back. How do you find a maximum in our class? We've been doing it for the last week or 2. How do you find maxes and mins? Take the derivative and set it
Equal to 0.
yes. Take the derivative, set it equal to 0. I want to take the derivative and set it equal to 0. Does anybody see a problem with taking the derivative of this thing? There's something wrong. Yeah.
We just turned to 1.
I'm sorry?
We just turned to 1. Oh, it's multiplied, right? So you
Yeah, X times Y.
did change over.
It is, well, it's a product rule.
Or product row.
But how many letters do we have in this problem?
Or 3.
3. We've never done one with 3 letters before. We had y equals x squared, that's fine. Never had one with 3 letters. There are too many variables. 2 we can handle, 1 on each side. We cannot handle 3. Is there a way to fix that? Yeah.
Could you set x, y equal to u?
Good, nice try. X, y equals u. Yes, but then you'd have to plug x, y back in and you'd have the same problem. Little hint. Go. Go. Oh, okay. What do you think? I didn't hear you. Oh, okay. Here's a hint. Can you find x? Do it. Becca, take over. Get x by itself. Just algebra.
Subtract 2y
Okay, as long as you do it too.
plus x.
Okay. So what do you get?
X equals 1200 minus 2y.
Yeah, 1200 minus 2y. I'm going to do negative 2y plus 1200. Same difference. Why would we do that? It just seems like a 30-second algebra diversion. It's kind of like, go.
We could substitute.
You can plug that in for x. Let me show you what it means. A equals negative 2y plus 1200 times y. Nate, do it.
Well, it's gonna be negative 2y squared
Negative 2y squared.
plus 1200y.
Now you can take the derivative. Do it. What's dA?
It's gonna be negative 4y
Okay.
plus 1200.
And you notice I'm not using prime notation? What do you have to put after every term?
Plus 1200 dy.
dy, and it'll be after each one. Plus 1200 dy. Nice. See how that works? So, factor out the dy. dA equals negative 4y plus 1200 parentheses dy. Divide the dy out. The only thing I'm doing is to get a, I agree, the dy was annoying. Just divide it out. So dA over dy, which is kind of like a prime, is equal to negative 4y plus 1200. Believe it or not, you're about 80% of the way done. First of all, let me just walk you through real fast. First, does everybody see where we got this formula? X plus 2y equals 1200? That's just how much fence and add up the 3 fence pieces. Then, they want us to maximize the area, which means take the derivative of the area, set it equal to 0. But I can't yet. Too many variables. But if you can get one of these variables by itself, you can plug in, and now we only have 2 variables, like this. And by the way, if you really want to, you can do prime notation. A prime is equal to negative 4y plus 1200. It looks a lot less messy. I don't want people getting too scared of the dAs, dYs, dTs, because you will need them, but we'll try this. Congratulations, you have your derivative. What do you do with it? Please. Set it equal to 0. Do it.
Subtract 1200.
Right. Negative 4y equals negative 1200. Keep going.
Divide by negative 4.
All right. What do you get?
Y equals 300.
Y equals 300. Look at the original picture. 300 what? 300 feet. How long is this side? Another 300 feet. How much fence is left? 600 feet. Congratulations, you're done. That is how you maximize area. This, if you want a technical name for what you just did, this is called an optimization problem. Optimization means to make best, make the best, to find the maximum or find the minimum, whichever one you need. In case you're thinking, well, finding the minimum is never optimizing, actually, yes, it is, if you minimize debt. You don't want to maximize debt, that would be awful. You also don't want to, minimize good health. It's like, oh, I got too much good health, I gotta get a minimum. Bad choice. Questions? That's an example of optimization. Now, your assignment, this is not due tomorrow. This is due, and if I don't make it blue fingerprints on this, sorry if I do. There are 4 problems. I'll give you more notes on this tomorrow. But for now, I'd like to take the rest of the hour, polish off both of the 3 H's? Yeah, so both of the 3H worksheets, the maxes and mins problem. I would like those both due tomorrow, i.e. Friday. And then this thing will probably be due on Monday. Okay. So you should have enough notes to get to answer number 1 if you get done with the 3H's worksheet. If you don't worry about it, because it's due Monday. Clear? Any last questions? So you should have the notes for both the 3H's, and you should have enough notes for a little bit of, like problem number 1 on the new worksheet. That should do it. Okay? All right, for those of you listening at home, Godspeed your health, and or good luck with soccer, and we'll, hopefully, probably not both at the same time, and we'll talk to y'all later. Bye-bye.